Ladies and gentlemen, welcome to section 11.2, Rational Functions, Part 1. We're going to jump right into things with our very first vocab word, rational function. A rational function is a nonlinear function where polynomials are divided by variables. So an example of a rational function is an inverse variation. Inverse variation is what we've been covering for a couple days. We have a couple curves on our graph that we've been graphing. And then next vocab word is now excluded values, which would have been our 0 for inverse variation. Excluded values. Any values of a variable that result in the denominator of 0. What does the denominator mean? The denominator is the bottom of the fraction, correct? Must be excluded from the domain. So excluded values, they cannot happen in the domain. The domain must not be 0. So how do we find these excluded values of the function? You'll like this. For finding excluded values, what we have to do, we take whatever is on the bottom of the fraction, on the bottom of the fraction, on the bottom of the fraction, and we set it equal to 0. And so now we set it equal to 0. Once we set it equal to 0, you say it can't equal 0. And so that's it. So for number 1, we set x equal to 0. We did not have to solve for anything, and we just said can't happen, x cannot equal 0. Here, what do we have to do? For excluded values, we have to take whatever is on the bottom of the fraction. We set that equal to 0. So x minus 2 equals 0. Now let's solve for x. So how do we solve for x? We add over that 2. So x now equals 2. But just like we did in number 1, x equals 2. But it can equal 2 because that would be 0 on the bottom. So x cannot equal 2. Going to 3. First step we have to do with excluded value, take the bottom of the fraction, set it equal to 0. 3x plus 9 equals 0. And now we solve for x, so we subtract the 9 over. So it's going to be 3x equals a negative 9 divided by 3, so x equals negative 3. Your favorite step, you say x cannot equal negative 3 because it would be 0. So if we check all these, if I put 2, this 2, in for this x, it would be 2 minus 2, which would be 0. You cannot divide by 0. You have 3 times a negative 3, which would be negative 9 plus 9, which would be 0. You cannot have 0 on the bottom of a fraction. So that's why we set it equal to 0 and solve for x, and then cancel out the equation. Our vocab word that finally comes up is asymptote. An asymptote is a line that the graph approaches. So if we look over here, this is the blue line is the graph right here. And so this blue line is going to approach this red vertical line, and that line is the asymptote. This red line is the asymptote. Same thing here. This blue line coming from the bottom will approach the red line but never really cross or pass the red line. It will get closer and closer and closer, but never pass the red line. Graphing rational functions. This is the formula for rational functions, or I should say the equation for rational functions right there. It looks like this with numbers put into it. The horizontal asymptote, ladies and gentlemen, will be the c. So horizontal asymptote will be this c right here. Whatever is added outside the fraction is going to be the horizontal asymptote. The vertical asymptote is whatever is underneath the fraction. So remember, when we set this guy equal to 0 and solve for it, that's going to give us our vertical asymptote. Now the assignment doesn't ask for the domain and range, but I'm going to give you the domain and range. The domain is going to be all real numbers except whatever your vertical asymptote is, because we solved and said it couldn't be x. So your domain is all real numbers except for what x can't be, and your range is all real numbers except what is added or subtracted to it. If we look down here with an actual graph here, my asymptotes are again these red lines where x equals 2 because the asymptote is at x of 2, and y equals negative 1 because this y is moved down to negative 1. In today's assignment, we are going to be asked to identify the asymptotes of each function. We're going to start with the vertical asymptote. The vertical asymptote is whatever is on the bottom, whatever is on the bottom of the fraction. So we just say x equals 0. That's going to be the vertical asymptote. If it was an excluded value, x would not equal 0. Now the horizontal asymptote is whatever is added or subtracted to it. Is there anything added or subtracted here? No, there isn't, so the horizontal one is going to be y equals 0 as well, because we're adding nothing to it, right? It's just like we're adding 0 to it. Looking at 5, remember the vertical asymptote is on the bottom, so we go x minus 3, and we set it equal to 0. Add over the 3, so x now equals 3. So our vertical asymptote is x equals 3. Or horizontal asymptote is whatever is added or subtracted behind the fraction. Is there anything added here? No, there isn't. It's just plus 0. So y equals 0. You like the horizontal asymptotes. Vertical, again, for number 6, what is on the bottom? This guy is on the bottom. We set it equal to 0. X plus 2 equals 0. And then solve for x. X equals negative 2. So our vertical asymptote is negative 2. Our horizontal asymptote, now is there something behind the fraction? Yes, there is. There's a plus 3. So y equals 3. And then finally for 7, we have to find our vertical asymptote, which is on the bottom of the fraction. Vertical asymptote is on the bottom of the fraction. Set it equal to 0. 4x plus 8 equals 0. Solve for x. So it's 4x equals negative 8. Divide by 4. So x equals a negative 2 for my vertical asymptote. Now your horizontal asymptote. What is added or subtracted to the back of the fraction, behind the fraction, to the fraction? Whatever is out here, not in here, is your horizontal. Your horizontal is y equals a negative 5. Now tomorrow's lesson, we are going to use these vertical and horizontal asymptotes to help us graph. So it's a good start to identifying and graphing your asymptotes and rational functions. And that concludes 11.2 Rational Functions Part 1. Good day.